Okay, so today we're going to look at a thing called the factor theorem. It follows on from what we did last lesson because we have to use polynomial division a little bit further along. But before we do that, I'm going to explain what the factor theorem is by using a couple of simple examples. So we've got this quadratic that we want to solve for equal to 0. How would we do this? Well, we would factorise it. We would say we would have x minus 4 and x minus 1 equals 0 because we want two numbers that multiply to make 4 and add to make minus 5. And then we'd say so either x equals 4 or x equals 1. But what does that mean? What it means is my solution of x equals 4, if I put 4 into my original quadratic, my answer would be 0. If I put 1 into my original quadratic, the answer would be 0. If I used any other number, it wouldn't be 0. So let's check it out. 4 squared minus 5 lots of 4 plus 4. Well, that's 16 minus 20 plus 4. Guess what? Yeah, it equals 0. So what you can do, you can almost do the reverse. You can think, well, let's try some numbers out. Let's try x equals 2. Well, I'd have 2 squared plus 2 lots of 2 minus 15. 4 plus 4 minus 15. Well, that doesn't equal 0. So x equals 2 is not a solution. Let's try x equals 3. Well, I'd have 3 squared plus 2 lots of 3 minus 15. 9 plus 6 minus 15. Guess what? That equals 0. So x equals 3 is a solution. And I could keep trying numbers to find out what all the solutions are. But as we know, if I actually went back to factorising that, I'd have x plus 5 and x minus 3 equals 0. So either x plus 5 is 0, so x is minus 5, or x minus 3 equals 0, so x is 3. So there's actually two ways of solving a quadratic. You can factorise it or use a quadratic equation, but you can use this method called trial and error. But then we have this link. If x equals 3 is a solution, x minus 3 is a factor. Up here, if x minus 4 is a factor, x equals 4 is a solution. If x plus 5 is a factor, x minus 5 is a solution. So you have this link, and that's exactly what the factor theorem says. The factor theorem says if I have x minus a, where a is a number, if that is a factor, then x equals a is a solution, and vice versa. If x equals a is a solution, x minus a is a factor. So, type of questions you might get. Show x minus 2 is a factor. Well, if x minus 2 is a factor using the factor theorem, x equals 2 is a solution. So, let's have a look. I would do 2 cubed plus 2 squared minus 4 lots of 2 minus 4. That's 8 plus 4 minus 8, minus 4. It equals 0. Therefore, x minus 2 is a factor because that equals 0. Now, you got to remember, if x plus 3 is a factor, x equals minus 3 is the solution. You have this thing where effectively the signs are the opposite. In the factor and as a solution, you have opposite signs. So you would say minus 3 cubed plus 3 lots of minus 3 squared plus 2 lots of minus 3 plus 6. Well, that's minus 27. That's going to be plus 27. Minus 6 plus 6, it equals 0. Therefore, x plus 3 is a factor. Okay, so how do we use this? Well, we use this to actually factorise much more difficult polynomials. So we use it to factorise cubics, quartics, polynomials to the power 5, 6, 7 and so on. Because there's no simple way of doing this cubic. With quadratics, you can think I need two numbers that multiply to that and add to that. Even when you've got the more complicated quadratics, there's no method for a cubic, a quartic and so on. So you have to use trial and error to begin with. But before we start just trying any numbers, there's only so many numbers that we can actually try. Because if I think about what this is going to look like, it's going to potentially look like this. 3 brackets multiplied together, each with an x and each with a number at the end. The only way I get this minus 6 on the end is to do this times this times this, which means, so if I call this A, B and C, my minus 6 is created by doing A times B times C. And that is really useful bit of information, because that means A, B and C have to be a factor of minus 6. So A, B and C have to be either plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. They're the only numbers that A, B and C can be. So that gives me the numbers to try. So I always try x equals 1 to begin with. 1 cubed plus 2 lots of 1 squared minus 5 lots of 1 minus 6. So I've got 1 plus 2 minus 5 minus 6. Don't even really have to work it out. I can see it doesn't equal 0. Now, if I've done the positive, I always do the negative, because the negative of the number of that solution is, the only thing that's going to be different is the signs, because minus 1 cubed, is going to be minus 1. Plus 2 lots of minus 1 squared is just going to be plus 2. Take away 5 lots of minus 1 is going to be plus 5, and then you've got the take away 6 at the end. So it's like the odd powers change sign and the even powers stay the same. And this one does equal 0. So that tells me x equals minus 1 is a solution. So that tells me x plus 1 is a factor. And if x plus 1 is a factor, then I know my cubic is going to be, so I'm going to write x cubed plus 2x squared minus 5x minus 6 is going to be x plus 1 times x squared plus 8x plus b. I know it has to look like that. And this is where it comes back to last lesson, because I now do my polynomial division. I've got an x cubed, so that needs to be x squared, that needs to be x squared. I want 2x squared, so I need an extra x squared, so that's going to be an x and that's going to be an x. I want minus 5x's, so I need to put a minus 6x there. So that's going to be minus 6, and that's minus 6, and that's my check. So there we go. So my cubic becomes x plus 1 times x squared plus x minus 6. Now it says fully factorise, so that means it wants us now to factorise this as well. Sometimes that can't be factorised, so that would be the answer. But if that quadratic can be factorised, you have to factorise it. And so we end up with x plus 1, x plus 3, and x minus 2. And there's your answer. So I'll do one more example, and then I'm going to get you to do some. Slightly more complicated one, because it isn't 1x cubed anymore, it's 9x cubed. But the philosophy is the same. If I think about my 3 brackets, the only way I get this minus a is to do a times b times c. So these have to be factors of minus 8. And what are the factors of minus 8? Plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. I'll be honest, in these sorts of questions, they tend to be one of these two answers, because they don't want you sat there trying different values too long. So, as always, start with the 1. And I've got 9 minus 6 minus 20 minus 8. Well, I'm not even going to work it out. I can see it doesn't equal 0. X equals minus 1. 9 lots of minus 1 cubed is going to be minus 9 minus 6 plus 20 minus 8. Again, that does not equal 0. Okay, the way I do that quickly is I look at all the positive ones and I've got 20, and I look at all the negative ones and think, do they equal 20? And the answer is no. So x equals 2. 9 lots of 2 cubed, which is 8, minus 6 lots of 2 squared, minus 20 lots of 2 minus 8, so that's 72, minus 24, minus 40, minus 8, and guess what? That one does equal 0. So x equals 2 is a solution, which means x minus 2 is a factor. Okay, so I have my 9x cubed minus 6x squared minus 20x minus 8 is equal to x minus 2 times ax squared plus bx plus c. Okay, polynomial division again. So I've got my x and my minus 2. I want 9x cubed, which means I need 9x squareds. Fill in the column. That gives me 8 minus 18x squared. I only want minus 6x squared, so I need a 12x squared there. So that means I've got a 12x, which means I've got minus 24x. But I actually only want minus 20x, so I need a 4x there. So that leaves me with a 4 on the end and a minus 8, and that's my check. So I end up with my cubic being equal to x minus 2 times 9x squared plus 12x plus 4. But now I've got to factorise that one. So I'm going to do it in red up here. I need two numbers that multiply to make 36. I've got 1, 36, 2, 18, 3 and 12, 4 and 9, and 6 and 6, of course, 6 and 6. So 6 and 6 is my two numbers I need to use. I had a bit of a mind meld there where my brain just went. So I've got 9x squared, 6x, 6x and a 4. Common factor of the top row is 3x. I've got a 3x there. So I need a 2 and a 2. So actually, my cubic becomes x minus 2, 3x plus 2 times 3x plus 2. Okay, and this is okay. It's just called a repeated factor, a factor that's repeated. So actually, if I wanted to be a bit more clever, I could write this as 3x plus 2 squared. You don't have to do that because both of those are fully factorised. But I've got x minus 2 times 3x plus 2 squared. Okay. Right. Oh, I think that was because I couldn't fit it all on. Now, the only thing is, occasionally it will then go to solve the equation. Well, if that's the case, if you then have to solve the equation, well, if you've got your three factors, then you just get to the point where you say either one factor equals 0, the other factor equals 0, or the final factor equals 0. So, for speed, I'm not going to do this one. I'm just going to tell you what the brackets would be. I do apologise, I'm cheating. I am going to use my calculator. And so I think they would be 2x minus 5. They would be 3x minus 1. And they would be x plus 1. Okay, so if I factorise that fully, I'd get that. So then I would just simply say either 2x minus 5 equals 0. So 2x equals 5. So x is 5 over 2. Or 3x minus 1 equals 0. So 3x equals 1. So x equals 1/3. Or x plus 1 equals 0. So x equals minus 1. Okay, right. Here we go. Just 3 for you to do. Have a go. And press pause. Press play and I'll show you the answers. Okay, so first one's quite nice because it actually you didn't need to use your trial and error. It gave you the first factor. You just had to show it was a factor. So yeah, put x equals 2 into the equation, get 0, therefore it's a factor. Do your polynomial division, and then you factorise the quadratic that you have, and you should have got x minus 2, x plus 3, and 2x minus 1. Okay, Second question didn't give you a start point, but you know you're going to have plus or minus 1, plus or minus 2, plus or minus 5, or plus or minus 10 as one of your answers. So again, I always start with 1 and minus 1. Now, I think the clue here is if these are quite positive, your factor's probably going to be a negative number, because this is going to be a big number plus a big number plus a big number, take away 10. It's never going to be negative if your x is a positive, which is why I didn't bother with x equals 2 and I just went to x equals minus 2. But it shows x plus 2 is a factor, so you do your polynomial division, factorise, and you end up with, I was going to say that, I didn't write the final answer, x plus 2, 2x minus 1, and x plus 5. And the last one. Okay, try. Now, 36 has got an awful lot of factors, okay? And it does have negatives, because remember, you could have a negative times a negative. Don't think just because you want the factors of 36 that it's only going to be 1, 2, 3. It could be negative numbers as well. Okay, now with this one, you actually did end up getting to x equals 3. Okay, so when x equals 3 is a solution, so x minus 3 is a factor, do your polynomial division to get that quadratic, and then factorise the quadratic, and you should have got x minus 3, 3x minus 4, and 2x plus 3. But that's not the answer to this question, because it wants us to find the solutions. So then we have to say either of those brackets can be 0. So either x equals 3, x equals 4/3, or x equals minus 3/2. Okay, hope you've got that. I've only done the one worksheet for this week, combining the 2 lessons. So have a go at the worksheet and see how you do.